notice some people have already watched it. So if you have watched it, this will be like a revision. Thank you, Mr. Samuel. But I'm drained. You know, teaching drains. So it's not easy to be a man. You got to hustle. You got to work hard. And teaching drains. Even though I enjoy it, I love what I do. But it drains when you have multiple classes. So sometimes you don't have a choice. You have timetable that will kind of just be like back to back, like that. I've taught cybersecurity class today. I've taught CCNA 2 class today, and you are CCNA 1. All right, so we want to talk about IP version 4. You know all this why we started this journey. I used to talk about IP address, IP address, IP address. I've even gone to show you guys from my command line in our last class where we saw the IP address of my computer using ipconfig. Please don't ever forget that command. You will always have a need for that command. Yeah, good evening, Mr. Mayweather. You always have a need for that command. ipconfig. Look at the IP address that I have on my computer here right now. If you have not been taught about IP addressing, you can't analyze this IP address. You don't know much. You can just call the numbers out for me. So this is what the roadside network engineer do. When they want to network, they have crammed 192.168.1. Then they maybe .1 put on one computer. Then 192.168.1.2 next computer, and so on and so forth. How? Why are you using that this IP address? Why are you using 192.1.168? They don't know. They can't tell because they don't know about IP addressing. So in today's class, we want to break down the concept of IP addressing. You're going to understand these things. So you can decide to build your own network and use something else outside of 192.168. All of this is you're going to understand. This is, when we do training, I call some topics core topic. Core. I call some non-core topic, not because those topics that I call non-core are not important for us to learn, but there are some that you can get away with even if you don't know much about them. What I'm trying to say is you can build a network, assign IP address to your computer, and things will work. Even if you don't know much about OSI model, things will still work. So you can decide to learn some things just having gaps in between. There are some, if you miss them, forget about it. No network for you. You can't build a network. You need to know about MAC address. You need to know about the IP address. And so this is a core topic. The very core of GCNA. Until you get to the peak of your career in IT, you're going to keep on coming across this. So you need to take note of this. So this class is very, very important. I can give people videos to watch on OSI model 7, not on IP addressing. IP addressing, I want to be the one talking about it myself, teaching, pushing, making sure that people understand what we're doing. So please follow me carefully. And it's a long journey, but we're going to get to our destination. So if we're going to spend up to 2 hours, no problem. When we get to our destination, I will have to, just a minute. Yeah. So IPv4 address. We need to talk about IPv4 address structure. Now, while are we saying IPv4? Because we're also going to come to another class where we will talk about IPv6. There is IPv4, there is IPv6. So you need to understand that. There is IPv4, there is IPv6. So what we will be talking about basically now is IPv4 address structure. So meaning whenever you see an IPv4 address, you can dismantle it. You can talk about it. You can explain things about it. And you can make use of it. So it's not going to be something you use accidentally. No, you know what you are doing. That is the point we're making here. You know what you are doing. That is the point we are making here. So before I come to this, let me show you something here. So when you say IPv4, you need to understand this statement here. An IPv4 address is a, look at it here, 32 bits. Here we go again. We have talked about bits. We have talked about decimal. Here we go again. So whenever you see an IPv4 address, it is a 32-bit hierarchical address. Take note, that is made up of a network portion and a host portion. Any IP address you see anywhere in the world, as long as it's IPv4, will be 32 bits and have two portions. And that is the first thing you need to be able to identify as we proceed in this journey today. So if I wrote this IP address on the screen right now, we worked with it in our last class. 192.168.1. I can't remember, maybe 254, whatever. This is a complete IP address. And I am telling you that this IP address you are looking at now is a 32-bit. What makes it 32-bit? If you convert this first decimal number into binary, you get 8 bits. The next one to binary, you get 8 bits. The next one into binary, you get 8 bits. The next one into binary, you get 8 bits. 8 times 4, that will give us 32. That is why they call the IP address, complete IP address, is 32 bits. And each of these boxes is what we call an octet. We call octet. So when you see an IP address, it's going to always be 4 octets, 32 bits address, hierarchical, and they're always separated by dots. That's the first thing you need to know. It is 4 octets, it is 32 bits, it's separated by dots. The next one is you need to know the network portion and the host portion of that IP address. So when you see an IP address, it can be broken into 2 portions. And we're going to find out how you break it into 2 portions. We're going to come there. So when determining the network portion versus the host portion, you must look at the 32-bit string. So you look at the complete IP address if you want to break it into 2 portions, or you want to know where the demarcation is. And what will help us to do the magic is called a subnet mask. A subnet mask. What is a subnet mask? A subnet mask is like a compass. A compass. It guides us. It is used to determine the network and the host portion of an IP address. A subnet mask is used to determine the network and the host portion of an IP address. So what is all this long story now? Let me break it down further. Let's go back to this my previous slide here. This was not part of the curriculum. I prepared this from my years of experience because I needed a better way to communicate some things to my students. Before you deal with any IP address, guys, you must be able to answer some questions. So whenever you see an IP address, first question you must be able to answer: class of the IP address. There are different classes of IP addresses. Some IP addresses belong to class A, some belong to B, some belong to C, some belong to D, some belong to E. We use class A, class B, class C. We don't go beyond that. So whenever you see an IP address, the first thing you need to be able to identify is the class of that IP address. Anywhere in the world. That's where we're going to start our journey. So when you identify the class of an IP address, you must also identify the subnet mask of that IP address. And these are standardized, guys. They are standard. Look at what I have now. Any IP address in class A, they have a range given to us. Any IP address in class B, they have a range given to us. Any IP address in class C, we have a range given to us. They even have their subnet mask, and all of this, you need to know them by heart. So how do you make sense of this? How do you make use of this? Very simple. Very simple. Let's bring back that IP address that I gave earlier. 192.168.1.254 is an IP address. So if you see this IP address right now, the first question you must be able to answer is, what class of IP address is this? What is the subnet mask of this IP address? And these are standardized. So how do you answer that question? Take a look at the first octet. Take a look at the first octet. What number do you have in the first octet? This is 192. From what I have on the screen here, where does 192 fall into? Take a look. Any IP address that is in class A will be from 1 to 126. Any IP address that is in class B will be from 128 to 191. Any IP address that is in class C will be from 192 to 223. So when you take a look at this 192 right now, you try to find out where does it fall into. Beautiful. Some people are already answering that question. That's good. 192 falls into C. It's between, look at 192 here. 192 to 223. That means this IP address is a class C IP address. This IP address is a class C IP address. I hope we are flowing. So whenever you see an IP address, you must know the class of that IP address. Let me give another example. If you saw something like this, let's say, let me give you guys, let me see if you guys will understand what I'm doing now. Let's say you saw 172.100.100.100. If I ask you right now, what class of IP address is this? You people should try. Drop your answer in the comment section. So please look well before you answer. Yes, B. All right, good. That means you guys are flowing with me. So why are we calling this IP address class B IP address? Because if you take a look at the first octet here, look at the number in the first octet. Look at this table I gave you here right now. Where does 172 fall into? 172 is between 128 and 191. Therefore, this IP address is a class B IP address. Let me go back to class C. 192.168.1.254. Second thing you need to know, whenever you see an IP address, apart from knowing the class of that IP address, you must also be able to tell me the subnet mask of that IP address. So you must know the class first, guys, before you talk to me about the subnet mask. And these things are standardized. Case in point, the one I have here right now, we have all agreed that it's a class C because there is 192 in first octet. So what is the subnet mask of this class C? Look at it in front here. The subnet mask of class C, this is standard anywhere in the world. By default, take note of that, by default is 255, write it under the IP address, 255.255.0. That is the subnet mask of class C. We refer to this as class 24 again. I'm going to talk about that later. So how do I make sense of this? We use the subnet mask, guys, to break our IP address into network portion and host portion. We use the subnet mask to break our IP address into network portion and host portion. So if you take a look at my IP address, which is 192.168.1.254, how many of the octets has 255 under? Look at the first one here. Look at the second one here. Look at the third one here. So I will carve these three octets together, and this is going to be my network portion. The remaining octet that has 0 under is going to be my host portion. I'm going somewhere. Just follow me carefully. Subnet mask is like a compass. It will help you to break your IP address into network portion and host portion. And you cannot break that IP address into two until you know the class and the subnet mask. We're going somewhere. You know the class, you know the subnet mask. With that, you can make that informed decision. Let me give you another example. Let's pick another IP address. Let's pick class B. You guys saw me with one class B the other time. This is another class B IP address. I believe you guys agree with me. 150. 150 falls in between 128 and 191. If I tell you right now or ask you right now, can you break this IP address into two sections for me, network and host portion? How will you do that? First and foremost, you need to identify the class. It is a class B IP address. What is the subnet mask of class B IP address? 255.255.0.0. Write it under it. 255.255.0.0. What does that mean? How many octets of this IP address has 255 under? 150.100. That is my network portion. The remaining two octets here will be my host portion. So we use the subnet mask, not only us, even the computer use the subnet mask to make this decision. That is why you see, when I show you guys my IP address, under it, you're going to see subnet mask. IP config. Look at it here. Look at the IP address of my computer. 192.168.1.96. And then I have a subnet mask under. This is what will enable this computer to know the network portion and the host portion of this IP address. Without the subnet mask, this computer does not have an idea of network portion and host portion. So why does the computer need to know about network portion and host portion? You are going to find out as we proceed. If the computer does not know about network portion and host portion, there will be chaos on the network. You will see as we proceed. So let me ask you guys a question now. Let me bring out another IP address. 10.100.100.100. Can you people break this into two for me? Tell me the network portion, tell me the host portion. And before you do that, you must answer the question first. You must tell me the class. You tell me the subnet mask, and you now break it into two. So let's try it sharp. I'll be waiting for your answer in the comment section. Yes, people are telling me it's class A. You are correct. You are correct. So continue the journey. Keep on work on it. I didn't just ask you guys for class, so break it down. Where's my network portion and where's the host portion? If you say it's class A, you are correct, but I need it broken down. Okay, some people are breaking it down already. I hope you are correct. Please don't type network is, say network portion, host portion. And somebody put 0.0.0. There's no 0. Don't. If you have watched my video, we're going to come to that. Okay. Ah, yes, you guys are flowing with me. Good. Network portion is 10 dots. Good. So now let's do it together, guys. So if you take a look at this IP address now, the first question is, what class of IP address is this? It is a class A IP address. Confirm. Class A. Where is my network portion? My network portion is, you can stop sending so that it will not be distracting us. Thank you. Okay, sorry, what is the subnet mask? The subnet mask is, we write it under 255.25.0.0.0. What does that mean? The first octet of my IP address is my network portion. The remaining three octets will be my host portion. This is key. This is very important, guys. any IP address anywhere in the world is the same concept. I always take my time when I get to IP address. I don't rush it. I take my time because you have to get this one. This one is a must for you to know. Thank you. Thank you for thumbs up. I'm going somewhere now. You will see why we're doing this, what we're doing right now. Okay. So why do we need to know the network portion and the host portion of an IP address? Let me give an example. Let's go back to class C. 192.168.1.254. It's an IP address. You guys know, we have all agreed about the network portion based on the subnet mask, and we know the host portion. Do you know the implication of this or how you make sense of this? When you are networking computer through a switch, let's say there are 4, 5, 6 computers connected to this switch. All the computers that are connected to this switch must be on the same network. When we tell you that the computer on the same network, what we are simply saying is this: all those computers have the same network portion. Whenever you connect computers together using a switch, they are members of the same family. They must have the same network portion. That is what we mean when we say they are on the same network. So what I'm trying to say is, let's say class rep has a computer. You put 192.168.1.1. Uche has a computer on the network to 192.168.1.2. Let's assume they belong to the same family. Lydia has a computer 192.168.1.3. Another person, let's say Roland, 192.168.1.4. You will see that all these addresses that I'm writing to all the screen right now, a portion of these addresses must be the same. It cannot change. If you should make mistake and go to any of the computers on that network and write 192.186.1. maybe 10, you have tampered with a section of the network portion. That computer is not a member of the family. Nobody will talk to that computer, and that computer will not talk to anybody. The only way to make that computer to talk to members of the family is by bringing in a router inside, because a router is an inter-network device. It makes people from different networks to talk to themselves. But as long as we're members of the same family, we're connected to a switch, we must have the same network portion. So whenever you hear people say, all these computers are on the same network, check the network portion. It must be the same all through. Let me give you another example. This is why I want to take down the video that I put on the internet. That I taught some guys this part. I put it on the internet. My wife listened to it. She complained. Why did she complain? I put all the names of the children and herself in that video. I used it to do example. She said she doesn't want that. So okay, when I do another video, I will remove that one and put on this one on the internet. My son name is Adeyemi. Mr. Uche is laughing. You know, women now, you have to be patient with them. My son name is Adeyemi. Let's assume myself and Lydia, Uche, Pedro, Hike, AK, and class 3, we are from the same family. So my full name will be Adeyemi Roland. You are still laughing. Then Uche's name will be Adeyemi Uche. Class reps will be Adeyemi, I think you should put OSI. And Pedro's name will be Adeyemi Pedro. I think who is there that I can remember. Lydia's the full name will be Adeyemi Lydia. You see that a portion of that name is constant, and that is Adeyemi, 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 Adeyemi. That is what put us or make all of us members of the same family. That is our network portion, guys. The portion that is changing, that identify you uniquely on the network, is called your host portion. So this Adeyemi is like the surname. Yes, you are correct, Mr. Samuel. I just decided to put it on that side since our network portion is on that side. So that Adeyemi is like the surname. It's consistent all through. So if you now say another family member, let's say Adeyemo, another set of people, Adeyemo, let's say Adeyemo Samuel, Adeyemo, let's say AK, Adeyemo, let's say, who else is there? Dr. Francis. This is another family entirely. They can connect to one switch and talk within themselves. We can connect to one switch and talk within ourselves. But the day we want to talk between ourselves, as in this Adeyemi's family want to talk to Adeyemi's family, you cannot connect the two switches together directly. We need to bring in a router in between. Why? A router is an inter-network device. It makes one family to talk to another family. That means the router makes different networks to talk to themselves. That is why you have hundreds and thousands and thousands and thousands of routers on the internet, because there are thousands and thousands of networks on the internet, different families, different networks, and all of us must be interconnected together. So you see the importance of that network portion. The computer need to know who belongs to this family, and it uses subnet mask. So we are just trying to see how the computer find out that okay, these guys are from the same family, so I can the switch will allow them to talk to themselves. But if you should make mistake when you are building your local area network, put somebody on a different network, it's not going to work. Take note of that. I'm going somewhere. Thank you, guys. So network portion, host portion. You see, the network portion cannot change. The host portion, it is the only one that will keep on changing. So whenever you see an IP address, you must know the class, you must know the subnet mask, you must be able to break that IP address into two portions and tell us the network portion and tell us, thank you, Mr. Samuel, and tell us the host portion. This is key, guys. It's key. It's key. If you know these things very well, there is nothing they will throw at you. I'm talking about this IP addressing portion, subnetting, IPv4. There's nothing they will throw at you as well as networking is concerned. If you know this, if you have this solid foundation, you'll be good to go. So you just need to know this, have this table in your brain. But we have not finished. We have not reached our destination, guys. We have more things to talk about. Let's continue our journey. 192.168.1.254. We've broken it down. We know the network portion, the host portion. We know the class, and so on and so forth. But we've not reached our destination. Whenever you see an IP address, take notes. Mark my words now. Whenever you see an IP address, you must be able to tell me whether it is a host address, network address, or broadcast address. Host address, network address, or broadcast address. Any IP address you see, you must be able to tell me. And it is very easy as well. How do I answer this? Very simple. First and foremost, let me explain all of these addresses. Whole address is an address that you can assign to a computer. Host address is an address you can assign to a computer. A network address, or let me put it this way, network address, broker, and broadcast address cannot be assigned to computers. Why can't we assign network address to computer? Because that address belongs to everybody in the family. For instance, now I say my son name is Adeyemi, and let's say all the kids that I put under me earlier, all the members of the family, if they have their unique name, Adeyemi Roland, Adeyemi Sam, Adeyemi Pedro, Adeyemi Lydia, and so on and so forth, and then somebody enter my house now and say Adeyemis, the person is calling who? The person is referring to all the members of the family. So we need to have an identity to represent everybody on the family. Because if I'm going to give you a contract, a job to go and do for me out there, and I draw the topology, I am not going to be writing, Mr. Uche, when you get to destination, give one computer 192.168.1.1, give the next computer 192.168.1.2, give the next. No, I'm not going to. I will just give you the network address, means the general name for that network, the family name. It is not left for you to know where you start picking IP addresses from. So when you see an IP address, you should be able to tell me. And another way to put it is this: there is no IP address you will see that is a host address that does not come from a particular family. Meaning, you should know the family name, general family name, not just the network portion. So I am saying this. You need to know when you see a network address, which is an address that represents all the members of the family or the family as a whole. That is one. One more thing. There is another address called a broker's address. If Uche has a message for all the members of the family, instead of sending the message to us one after the other, he can just pass it to a particular IP address, which is called a broker's address. When the switch sees that this message is going to the destination IP address is broker, the switch will replicate and send it to everybody. Just like when we were talking about broker's MAC address. I told you guys that time we're coming to IP address too. So there is an address called network address. There is an address called broker's address. There are addresses called host addresses. And you need to know the difference. Broker's address is what the computer uses to talk to all the members of the family. Network address is an address that can be used to represent the family generally. We use it when we design the network. Host addresses are the ones that we assign to computers one after the other. So how do you identify the network address? How do you identify the broker's address? The easiest way. Let me give you the easiest way, guys. Thank you. 192.168.1.254. Let's write our subnet mask under it again for class C. You and I have agreed that the first 3 octets is our network portion. The last octet is our host portion. One more thing I forgot to mention when we started this journey. In every octet, the range of the address or the numbers in every octet is from 0 to 255. Meaning what? This octet now, this 192 falls in between 0 to 255. 168 falls in between 0 to 255. 1 is between 0 to 255. 256 is between 0 to 255. It therefore means you can never have an IP address that will be 300 dots, 400 dots, 1000. No, that can never be anything like that. It will always be between the range of 0 to 255. So therefore means 0 is the first number in every octet, and the last number in every octet is 255. Look at this 254 now. It's in between 0 and 255. So this is our network portion, guys. This is our host portion. How do I know the network address? Now listen to what I want to say now. When all the bits in the host portion are all turned off. What do I mean by that? When all the bits in the host portion of an IP address are all turned off, then that IP address is a network address. What do I mean by that? If you convert 0 to binary, you are going to get 1, 2, 3, 4, 5, 6, 7, 8. This is what we mean by the bits are turned off, because 0 means off in network. So it therefore means, I don't want you to cram it this way. Whenever you see 0 in the host portion, that means that IP address completely is a network address. So if we have something like 192.168.1.0, this is our network portion. This is our host portion. If we convert these zeros to binary, it will give us 8 zeros. So this IP address as a whole right now, it's a network address. So whenever you see an IP address, look at the host portion. Are all the bits turned off? If the answer is yes, then that IP address is a network address. Like the one I have on the screen right now. If you convert 254 to binary, you can't get zeros all through. You can't get ones all through. It's going to be a combination of ones and zeros. I'm talking about the host portion now. Our concern now is in the host portion. When all the bits in the host portion are all turned off, then that IP address is a network address. Or you can put it another way, this way. Whenever you see an IP address and they were asking you for the network address of that IP address, meaning an address that can represent the whole family, just look at the host portion, turn off all the bits and bring it out for us. Like if I brought this one out now, 192.168.1.0, that is where this one came from. This is a network address that gave birth to this guy here. So this one is one that will represent all the members of the family. So if someone is saying they are DMEs, this is a network address. When all the bits in the host portion, guys, are all turned off, it's a network address. But if it is not turned off like what we have here, it's not a network address. This IP address here is not a network address. Please give me thumbs up if you are flowing with me. Thumbs up. I will give room for question very soon. When all the bits in the host portion are all turned off, then that IP address is a network address. Don't cry when it is 0. When all the bits in the host portion are all turned off, then that IP address is a network address. One more to show you guys. What about broadcast address? 192.168.1.254. Same IP address. If I ask you a question now, can you tell me the broadcast address of this IP address? Meaning, which broadcast address we did be using in this family? Can they use? Very simple. Same thing we did, the reverse. Put the subnet mask. Know your network portion. Know your host portion. Now, the reverse is the case for broadcast address. Take note. When all the bits in the host portion are all turned on, if you convert 255 to binary, you are going to get 1, 2, 3, 4, 5, 6, 7, 8. So it means all the bits here, if we on it now, we are going to get 192.168.1.255. That means these bits in the host portion have all been turned on. So when all the bits in the host portion are all turned on, then that IP address is a broadcast address. This is what Uche can use to reach all the members of the family. Nobody, no computer will accept this. Why? Because all the bits are turned on. And I'm going to demonstrate that to you guys now. So this is what some students used to do, and I don't want you to do that. They will cram. You cannot use the first number in the host portion, and then you cannot use the last number, because I said the range of their numbers in each of the octets is 0 to 255. So they will say you can't use the first one, and you cannot use the last one. You can only use .1 to 254, and those will be our host addresses. It is applicable, or it makes sense with class C, but you see when we get to class B and when we get to class A, it doesn't work that way. You can't cram when you have .0 is a network address, when you have .255 it's a broadcast address, 1.1 to 254 it's our host addresses. It cannot work like that. It can work like that for class C. It can't work like that for B and A. So you got to be careful. So the best way is check all the bits in the host portion. If they are all off, it's a network address. If they are all on, that IP address is a broadcast address. Let me prove it to you. I'm going to go to where we can assign IP address to computer. I need you guys to follow me. It's one of the things that I want to talk about here. I will go to my control panel. Thank you. Go to my control panel. Go to network and internet connection. It will bring me to this place. I will click network and sharing center. It will bring me to this place. I will click change adapter setting. Then look at all the cards that I have. This is my Wi-Fi. I have one that is for my virtual box. So I want to use one for virtual box because I don't want to change the one for Wi-Fi. I am using it to browse. So now I will go to this my card. Take note now. If you want to assign IP address to your computer statically, manually, you right click. If it is the cable port, you right click it. If it is Wi-Fi too, you right click it. So when you right click it, you go to properties. Then it will give you this dialog box here. Then coming down here, you're going to see TCP/IP. I've talked about this one before. TCP/IP version 4. There is version 6 down here. We're not using version 6 now. We're on TCP/IP version 4. You select it. You come to properties. Now look at what I got in this place. There are two ways to get IP address. You can tell your computer obtain automatically. And if you should tell computer to obtain automatically, that means there is a server somewhere called DHCP server dishing out IP addresses to your computer. But if you don't have that, that means you want to assign IP address to that computer manually or statically, which is not what people do. People use DHCP. But for the purpose of this explanation, I want to show you, okay, let's assume I want to put a static IP address. I'll click use the following IP address, and then I'll come down here. I will put one of those IP addresses on this computer. Let's say I want to give this computer 192.168.1.254. Now, you see that the computer automatically put the subnet mask for me because the computer knows that this is class C. I will click OK. You see that the computer will not complain. But guys, let's put the network address based on our analysis now. Let's change this into 0. You and I have discovered that this is 0. I mean, if we put the .0, that's our network address. If I click enter right now, can somebody see what the computer is telling me? The computer said, Kai, there's a fire, there's fire on the mountain. The combination of IP address and subnet mask is invalid. Why? All the bits in the host portion, in the host address portion of the IP address are set to 0. Please enter a combination of IP address and subnet mask, a valid combination. So the computer says, the host portions are all turned off. This cannot be used here now. So the computer will never accept the network address from you. Never under IP version 4. Never. Because it knows that all the bits are set to 0. It knows that this is a network address that represents all the family. That's a general family name. You can't give it to one computer. It's okay. What about the broadcast? 255. If you put broadcast here, the computer will complain again. The combination of an IP address and subnet mask is invalid. Why? All the bits in the host address portion of the IP address are set to 1. Computer has converted our 255 to binary, and he knows that, boy, there is 1 all through here. This cannot be used here. This is a broadcast address. No computer can have a broadcast address as its own IP address. That is what I'm talking about. Computer will never collect network address or broadcast address from you. You need to take note of that. You need to know that like you know yourself. So how many questions are we answering now? Thank you, guys. So whenever you see an IP address, you must know the class. You must know the subnet mask. The subnet mask, you must be able to tell us the network portion and the host portion of that IP address. And the next one is this. You must be able to tell us whether it is a host address. Host address simply means it can be assigned to computers or broadcast address. These are the questions you must be able to answer whenever you see an IP address. Whenever you see an IP address. Thank you, guys. So, I am going to give room for questions now. Before I give room for questions, I will put an IP address on the screen, and I'll ask you guys what type of address is this. Case one, let me give you 150.100.255.0. I need you guys to look at this IP address critically. Tell me the type of IP address you think this one is. Take notes. I didn't say class. Type. Is it a network address or broadcast address or host address? Meaning, can I assign to computer? Take a look at it. Do your analysis and drop the answer in the comment section. Yes, people are telling me network address, network address, network address. Okay. Network address, network address, network address. Anybody that get the answer correctly will pay for my dinner. It's a network address. If you get the answer correctly, you pay for my dinner. Network address. Network address. Lydia, network address. Dr. Francis, network address. Who else is there again? Oh, yeah, keep it coming. What type of address is it? Oh, Osuna is a host address. Okay, we'll find out. Daniel just gave me thumbs up. He didn't tell me whether it is a network address or broadcast address or host address. Somebody said broadcast address. Lucky said network address. Somebody say class B. We're not asking for the class. That's you are supposed to do that analysis before you come and answer my question. Network address, network address, network address, network address, network address, network address. There is a broadcast address. And I did that deliberately. So let's analyze it together, guys. Let's analyze it. Oh, Limo says it is a reserved IP address. No, there's nothing like that here now. So let's analyze it together. First question, what class of IP address is this? This is a class B IP address. B. Class B IP address. Okay, you can stop answering the question. Let's do it together. This is a class B IP address. So I will bring the subnet mask down under it. 255.255.0.0. That is my subnet mask. Next question. Where is my network portion? Where is my host portion? Look at my network portion here. 150.100. This is my network portion. Where is my host portion? Look at these two octets will be my host portion. Now, our attention now is on the host portion. Are all the bits in the host portion turned off, guys? Are they all turned off? Or are they all turned on? So if you convert 255 to binary, you get 1, 2, 3, 4, 5, 6, 7, 8. If you convert zeros to binary, you get 1, 2, 3, 4, 5, 6, 7, 8. They are all combination of host portion. It's a mixture of ones and zeros. In this host portion, the host portion of this IP address, they are not all turned off. They are not all turned on. So what does that mean? It's a host address. It's a host address. Look at the host portion. That's why I said don't cram that .0. That's why I did this deliberately. I deliberately started with class C because some people, when they see .0, they will just cram it and say it's a network portion. Because in class B, there are 2 octets for the host portion. You have to factor in those 2 octets. Are all the bits there turned off? Are all the bits there turned on? So what will be the network address where this IP address came from? That will be 150.100.0.0 when all the bits are turned off. This is a network address that gave birth to this IP address. So what will be the broadcast address of this IP address? 150.100.255.255. You turn on all the bits in the host portion. Here you off all the bits in the host portion. What I gave you is a combination of on and off in the host portion. So this IP address is a host address. Personality got it. I don't know whether by mistake or deliberate. And somebody. You must be able to analyze this. Don't cram .0. Don't cram .255. Look at what you have in the host portion. Don't cram .0. Don't cram .255. Check the host portion. So let me give you another one. Then I will give room for question after that. Let me give you class A. So what if I give you something like this? 10.0.255.255. Guys, what type of IP address is this? Host address, network address, broadcast address. So you can drop your answer in the section. Okay, Derek said host address. You find out. Mr. Simon said broadcast address. Lydia said network address. Even with this, my calculation, some people are still saying network address, host broadcast address. With this explanation that I did in class B, please do your analysis very well. Do it again. Somebody say, what is the mask? This is class what? You answered that question now. I've taught you guys now. Check out the table on the screen. Dr. Uche, you say broadcast address. Do your analysis again. Or Mr. Uche, do your analysis again. And I know I'm good at doing this. Every time I teach this part, I'm very good at doing that. Host address. It's like people are thinking again. Host address. Okay. Oh, sorry. What is it? Host address. Okay. So let's do it together, guys. Let's do it together. First question. What class of IP address is this? If you don't answer that question, you cannot answer the final question. It is a class A IP address. What is the subnet mask of class A? 255.0.0.0. Write it under it. 255.0.0.0. So this is the IP address that we're analyzing. Where is our network portion? This is our network portion. Only 10 dots. The remaining part, limo, listen, no, stop writing stuff here. This address is not the broadcast address. 10 dots is our network portion. The remaining 3 octets is our host portion. Are all the bits turned on? Are all the bits turned off? If you convert zeros to binary, you get zeros all through. So you're going to get something like this: 1, 2, 3, 4, 5, 6, 7, 8. If you convert 255 to binary, 1, 2, 3, 4, 5, 6, 7, 8. The last 5, 1, 2, 3, 4, 5, 6, 7, 8. They are all sitting down together in the host portion. Are they all turned off? No. Are they all turned on? No. So what is it? It's a host address. So why is some people calling it broadcast address? Look at the host portion. Factor in all the octet that makes up the host portion. On them all, it becomes a broadcast address. Put them off all through, it becomes a network address. That IP address becomes a network address. For those of you that miss it now, I don't know if it's clear to you. Mr. Ochi, is this clear to you?